Hansi, ready? Finding the domain and range of a function. There's a few things you need to know. Ready, Hansi? There's actually two pieces you kind of need to know. What can't you divide by, Hansi?
Zero.
Zero. It's very important. From here on out, it's a very important concept. Got it? Don't forget it. And never divide by zero. It's always going to mess stuff up. When you type something into your calculator, you might get errors. It'll say like error. Like can't div zero, meaning error, can't divide by zero. The other thing you can't do, Hansi, is you can't take the square root of what type of number?
A negative.
A negative. In your calculator, that'll come up error, non-real answer, meaning you don't have an answer that you can kind of encounter in this real world. Like I can encounter the square root of 2. Like it's not going to be a pretty number, but I can actually like encounter it. I can create it. Okay, I can make like one side of a triangle 1, another side of a triangle 1, and the diagonal is the square root of 2. Like I can do that, but I can't actually come encounter with the square root of a negative number. So those are two very important concepts. So moving forward, when we're dealing with the domain and range of functions, that's something I need to pay attention to, okay? So up here, if we're looking at this one, it says f of x, meaning a function of x, equals 1 over x minus 3. And then it says my answer is domain is all x values other than 3. Why is it other than 3? Well, notice I have a fraction here. And Hansi told me I can't divide by 0. So what I do is I take the denominator and I set it equal to 0. And I solve it. That gives me x equals 3. So when I'm talking about my domain is all real numbers except for 3. Now, the way I like to write it is I'll write all real numbers, because I'm lazy. That fancy R stands for all real numbers, except x cannot equal 3. I'll kind of write it like that. You okay with that, Mr. Woolery? Over here, Hansi said, well, we can't take the square root of a negative number, right? So we take what's underneath the square root symbol, and it has to be greater than or equal to 0. Why? Because if it was less than 0, it would be negative. So here, that's where that domain comes from, where it says all real numbers except or greater than or equal to 0. Now for this one, I'm not writing all real numbers like that fancy R, because I feel this is enough. You'd write domain, x is greater than or equal to 0. Nice and easy. All right, so let's look at A. Ready, Hannah? Square root, right? So we know what's underneath that square root has to be greater than or equal to. Does it have to be greater than or equal to? 0. So what you're going to do is you're essentially finding out where it can't be, and then your answer is everything else but that. Ready? So 2x minus 6 has to be greater than or equal to 0. And we're going to solve that. How would you solve that, Hannah? Very good. So your domain would be x is greater than or equal to 3. That's it. Okay? Makes sense? Leah, what can't we divide by? 0. But now we have two things on bottom, right? So I have to find out where both of them equal 0. So I'm asking, when does this equal 0? And when does this equal 0? When does this equal 0, Leah? So this one, I would say, my domain is all reals except for x cannot equal 1 or -5. Now I'd write it something like that. Now let's say this inevitably will happen, okay? And I feel like it's going to happen to Justin. Justin's going to be like, whew. What do I write again? Ready for this, Justin? Say you forget that fancy R on the tabs, right? All you write is all real numbers except x equals -5 and 1. Okay? You could write it out. Both of these things mean the same thing, right? So you convey your knowledge to me, and then we'll worry about it later. Make sense to you? Jake?
But why is it except this?
Because if x is 5, that's 0, and you can't divide by 0. And when x is 1, that's 0, and you can't divide by 0. Okay, that is what we call a hole. So like before, our graphs were continuous, meaning we didn't have any gaps, but now we have holes. Meaning at that point, our function is undefined. I can't get a value for it, okay? And that's where this is going, all right? So these things are called holes in your graph, okay? Over here on that one, it just, my graph doesn't live there. Like it doesn't exist. These, you'll see, it exists everywhere, except if you were to zoom in, right there, there'd just be like a little hole. Now, as we know, there's two parts. There's a domain and range. Okay, so find the domain and range of each function. Okay, up here, domain. The domain is going to be all of my x values, which is -3, -1, 0, 2, and 4. Okay. -3, -1, 0, 2, and 4. And my range, well, that's going to be all of these guys. So 0, 2, 4, 4, and -1. You guys okay with that? Nice and easy? It's not hard. Jake, you okay with that? Hansi?
Yep.
Who you texting?
Actually, my phone on my desk. I'm admiring my shoes.
Oh, you're admiring your shoe. What kind of shoes you got? The Yeezys?
500. Yeah.
They are?
Yeah.
You spent a lot of money on them.
Actually, no, I got them for a steal. Market price right now is over $400.
For those?
Yeah.
Sell them.
No, I'm keeping them. I got them for like.
But you're wearing them.
Yeah.
So you're decreasing the value.
Yeah,
You want to do a math problem about it?
I already bought them.
It's like the van problem. It's like the van problem in 3.5.
How much did you buy them for?
I got them for like 180.
They fake.
It's such a good price.
They fake.
I got them on go. I never used. So I had to clean them up.
Fake.
And now they're all stinky.
They fake.
Yeah. Tell me what's wrong with them.
Well, they're dirty, and I'm not touching them.
I cleaned them real nice.
So they fake. All right.
Yeah, black light all the authenticity.
That's okay. They still fake. I can print one out from my computer too. Doesn't take that long.
What, a black light?
Yeah. Make one on my computer. You know, they get 3D printers. All right, let's look at B, area of a circle. Here's funny things about area of the circle. Area has to be what?
Of what? A circle?
No, just think about it in general. Area.
The whole.
So this is where you kind of have to bring in like personal experience. All right. So think about it. You have negative numbers and positive numbers, right? So something's either positive or negative. Area. What is it? Is it going to be positive or negative? Positive. Has to be positive. You can't have a negative area. All right. Like, I don't even know how to explain that to you. It'd be like a kind of black hole type of deal. All right. So area has to be positive. So my domain here would be R has to be greater than or equal to 0. Well, why is that? Well, R is a radius. It's a distance. Can't have a negative distance, right? Like, if you were less than it, it just wouldn't exist. So your domain has to be, R has to be greater than or equal to 0. And your range, let your area, that's what Justin said. Well, my range has to be greater than or equal to 0 as well. Okay? Because it just stops at 0. You can't have negative area. You can't have negative distance. Okay. You work in the marketing department of a soft drink company where you're experimenting with a new can for iced tea that is slightly narrower and taller than a standard can. For experimental can, the ratio of the height to the radius is 4, okay, as shown in this figure. Rate the volume of the can as a function of the radius. Find the domain of the function. So I don't know if this ever bothered you guys, but when you go to like the supermarket, everything is round, like soda can round, right? Bottle round. Okay? Coffee cup round. Why is everything round? Like when you try to put two things that are round next to each other, right? You have that gap in between, it's just wasted space, right? Have you ever tried to stack like soda bottles on top of each other? You can't do it, can you? Like cans you can, but then you have those like spaces. Why is everything round? Do you know? Does anybody know?
Easier for like for the fluid house.
Maybe,
It's safe
right?
for children.
But why not? But why not have it like square? Right? If it's square, I can stack things on top of it, right? And it would fit in a, like everything at the supermarket is like box shaped, right? Think of like cereal. Cereal's all boxed. They all fit nicely in that little cubby that they have, right? Fits nicely in your cabinet. But circular things don't. Why? Why are cans like circular?
They can hold more. Is this like part of the problem? Are you asking?
This is like, no, I'm asking, like, I want to know. So Hansi says, oh, because they hold more. Well, I could just make a, you know, like a box, like a cube that holds the same amount, right?
It's easier to hold.
Easier to hold. That's why everything is round. Thank you, Nikki Grantland. It's easier to hold. Like holding a coffee cup in your hand is easy, right? Holding this in your hand, like notice, like see the gap there? So yes, I might be able to fit more on my shelves, but it's more of an inconvenience to the consumer. And you don't buy things that, you know, hurt your feet like fake Yeezys, right? So after a while, this will hurt your hand. Okay? Like this is not comfortable for me. So that's why it's round. But then there's this like kind of like somebody's job is to kind of think of like, how can I fit more of my product on the shelf? Because I pay for shelf space. So they come up with these cans that are narrow, like Red Bulls, right? Do you ever notice like a Red Bull's like the size, like holds just as much as like a Coke can, but it's like thinner and taller? Same thing, okay? So here, write a volume function for the can. So for A, we have a volume function. How do we get the volume of a can?
Height divided by the radius.
No. Anybody know the volume of a can? I'll give you a hint.
H over R.
Anything that's like a prism shape, like a box. No, that's not it. Because I want the volume formula. Okay, anything for a box, or like a cube or a prism shape, just as long as it doesn't come to like a point, is going to be the area of the base times the height. Area of the base times the height. Now watch this. Which shape is the base of a can? Circle. So what is the area formula for a circle? Pi r squared. Right? So pi r squared. Now it says the height, right? You see the height? That's h. Now we fill in what we know, right? So now I have the volume formula, okay? But I have r squared and h. I can't really do anything with that, right? Because there's two variables. Now this is where Hansi's comes in. Hansi, you were giving me this piece of information up here, right? Where it says h divided by r equals 4. Can you solve that for h?
Yeah.
Okay, what does h equal? H divided by r equals 4. Just
equals 4R.
h equals 4r. Now I'm going to come back to my volume formula, and I'm going to plug that in. So my volume of my new can is 4 pi r cubed. So it says find the domain of the function. Okay? So I wrote the volume of the can is a function of the radius. I'm only using r. So my domain is, my radius needs to be greater than 0 inches or 0 centimeters. Jake?
Where did you get the 4R?
Up here, this piece of information that it told us in the problem. For your experimental can, the ratio of the height to the radius is 4. So it says h divided by r equals 4. I have to solve that for one of the variables. In A, it tells me that I want it in terms of r. So it means I have to solve h in terms of r. So h equals 4r. So in my equation, I substituted in 4r for h. And that gives me that. Now it says write the volume of the can as a function of the height. Okay? This is a little bit trickier. All right? So for B, okay? So we have this formula, V equals pi r squared times h, but now it says it wants it in terms of h. So instead of having it as h divided by r equals 4, okay, I'm going to have h over 4 equals r. Where did I get that from? I just solved it for r. So now I come down here and I have v equals pi. Instead of writing r, I'm going to write h over 4 squared times h. That gives me pi times h squared over 16 times h, which is pi h cubed divided by 16. And my domain for this, my height has to be greater than or equal to 0.
Wait, why is it that R greater than or equal to 0 and
Your R stands for radius, right? Can you have a negative radius? So that's why it has to be greater than 0. It could be equal to 0, but that would be kind of pointless. But it could be, right? You just wouldn't have can.
I'm just confused about this part.
All right. So
Again, on the next page.
no.